I'm really taking x squareds from here, so that leaves a 1. And this one has an x, so it leaves a single x below. I'm really taking x squareds. And x squared that I'm taking away inside is a single x outside. That's how that happens.
Wouldn't it be 4 over x squared?
No. It looks like this. Just the bottom part alone. That's why you should take these in the summer. There's just not enough.
What?
You should take these classes in the summer. There's just not enough soaking time. Soak this junk
Then
in.
why did they offer it anyway?
Don't get me started.
You should have told us the first day.
It's kind of late.
Yeah.
Drop, right?
No,
Like,
really
oh yeah, he's
drop.
right. I'm just gonna take this in the fall. Yeah.
Yes.
Whatever. You wouldn't have listened. You would not have listened.
How you know?
Well, I don't want you to listen so much. I gotta keep at least like 7 of you in here or something, right? Otherwise, we'll drop the whole class. I won't
Don't
get
you
paid.
get paid?
Well, I mean,
You won't get
if
paid.
So
everybody
I
dropped,
can only tell a few of you.
That's a
But
conflict
you
of
know,
interest.
we're at that point.
if
Or
everybody
conflict
dropped,
of
would you
interest.
still get paid?
If everybody drops?
Yeah.
No, class is over.
You wouldn't get paid?
No, the class terminates. I don't get paid.
Don't you get a deposit though?
Deposit?
Yeah, like
What?
Like,
For
for just
hoping there would be a class?
teach.
Then they pay me for the
You know what you
psychological
could-
damage they caused me?
no, like
What?
they.
You know what you could do though? You could keep all of us. You could just give us the
Yeah.
Word would leak out. See some your little video there. Word would leak out, you know? And the next thing you know,
answer. Well, you can get rid of all of them and keep me all the time.
just alright.
We can get rid of people.
Yeah.
I know people.
Yeah, you're
Dude, we're
gonna
gonna play
you'll take them up to the 8th floor, show them around. Right? Anyway. You guys understand that joke, don't worry about it. Alright. So if you're gonna take an x squared from here, it's gonna read like this. X squared, you factor off, you'll have a 1 plus 4 over x. Agreed, Raja?
Yep.
This one has an x, so you have only one x underneath, not an x squared underneath. But now you want to take the x squared out. So this is a product of radicals. You can do this, right? But what's the square root of x squared?
X.
Right. But here's the mistake I made with Lee that one time, right? I need to do that out, right? Remember that?
Yeah.
Right. I mean, it's not an issue this time. It's going to cause infinity, but you know, you should be very careful about these things.
It looks like you lose a power as you go out.
That is what it looks like, but you're not.
Would it be right to assume it that way as you're pulling it out? That like when you have like x cubed in there, you're losing the power as you're pulling it out. So it would be at.
Well, it was a cube root then. It'd go down to 1.
Yeah, like it's like the square root you're trying to take out. So it'd be.
It's the first power then.
Yeah, to the first
That's
power.
correct, yeah.
Yeah.
Basically, yeah. Alright, so now we have this. The x's cancel, and since they're both positive, right? X and x are positive infinity, so both these x's are positive, so the absolute value didn't do much in this case. So those cancel. So if we look at it now, it's pretty straightforward. 2 plus 4 on x over 2 times the root of 1 plus 4 on x. As x goes towards infinity, these two parts here are heading towards 0. The negative value is straightforward. This is 2 over 2 times 1, which is 2 over 2, which is 1. So now we know this piece down here, this whole expression, is heading towards 1. So the answer is negative 4 on 2, which is not add anything, just negative 2. Right? If we would have pulled the x's out here, we get the same conclusion, a tad bit faster. Okay?
If you have what?
If you had taken out an x here, I suggested here that you could take out a factor of x from everything, and the problem would end itself more quickly. But I wanted to try to show what L'Hopital's rule would do in this case. What it does is it gives you this same expression back again, and it's always going to keep doing that. Every time you take L'Hopital's rule, it's going to be the same expression. So there's no point in doing it again.
On the test, or we just like completely just pull out of it?
Yeah, if that's the question you get, yeah. It's not going to say use L'Hopital's rule, right? More than likely, it will be a problem where you need to.
Okay.
Okay. But much like the question on the last test about the inverse derivative question, where it was tan, some of you took tan inverse and differentiated it. Got 1 over 1 plus x squared and plugged in the number. That was fine. You're supposed to use the formula that dealt with inverses without finding the inverse. Either way is fine. It didn't really say what to do specifically. So the technique used was irrelevant. All right. That was, oh God. So indeterminate powers now. Last indeterminate case we have.
Ugh.
What I'm going to do. Maybe not. What I'm going to do is indeterminate powers. There are three basic types. As opposed to the last two things we did, there's only one basic type for each one. So indeterminate quotient divided its indeterminate powers. So this is the case we have a function and it's being raised to another function. So, what is it? No, that's not right. No, that was not right. Honestly. So, 1, if the base is heading towards 1, and the exponent is heading towards infinity, it's a question what it's heading towards altogether. Right? Don't know. Why is it indeterminate? Why? Shouldn't the answer just be 1? 1 to any power is 1, right?
Well, you could have negative fractions. It can be negative infinity, and you can
No negative infinities.
get.
Positive infinity. The issue is, remember, f of x is heading towards 1. It's not 1 yet. It's heading towards 1. And you're raising it to some colossal power. So even if it's like 1.0001, you raise it to the 10 to the 5 billion power, well, that's possibly pretty big. Or it's possibly really close to 1. It depends which one's heading there faster, right? It's all about speed. Which one's heading there faster? If this one's heading faster than this one, then it's going to become infinitely large. If this is heading faster to 1, faster than it's heading towards infinity, then it's going to converge to some finite value. Possibly 1, possibly something bigger. I don't know. Okay? And infinity to 0. What is anything to the 0th power?
It's so one.
Except for what? 0. Right. So that's why I got a question here. 0 to the 0, what's it going to be?
0.
Who says? Maybe. Maybe. So in this case, if the power is heading towards 0, these are those things what they're heading towards. These are not the things themselves, right? The function f is not 0 and g is not 0. F is heading towards 0 and g is heading towards 0. So if the exponent is heading towards 0 faster than the base is, it's heading towards 1 altogether. If the base is heading towards 0 faster than the exponent is, it's heading towards 0, right?
So if you took the derivative of both of f of x and g of x, and if derivatives were the same at a certain point, would that just mean that that's the intersection point, or that's where it would equal each other?
The derivatives were the same?
Yeah, like let's say the rate of change was the same for both for g of x and f of x, it would remain true, right?
At the location you're heading towards?
Yeah, like the slopes are exactly the same. It's almost you have the same exact two functions, but they're written a little bit differently. It would equal 0 with 0, so it would be 0, right?
Okay, well, no, it depends, because remember this is a power, so it also depends on the position of the piece.